All right. Good morning, everyone. My name is Yan. I'm a principal engineer at a company called The Zone. We are based in London, UK. And you can think of us as a platform like Netflix, as in being affordable and a subscription-based platform for sports. So we let you watch live sports as well as sports on demand. And at any moment in time, we have around 500,000 active users on our platform. And we support all kinds of different sports and all kinds of leagues all around the world. And right now, we are in 5 different countries, including Canada, and available on more than 30 different platforms, including iOS, Android, Apple TV, and some really, really ancient set-top boxes in Japan. And the good news is we're also coming to the US in, I think, a couple of months' time at the end of summer. So, be on the lookout for us if you're a sports fan. Hey, thank you. Like everybody else here, we're also hiring. Just not in the US just yet. So if you're interested in working for us in London, then check us out at engineering.thezone.com. So on a more personal note, I've been working with AWS for about 10 years now. And in one of my previous companies, I did a bit of work with Serverless, where I migrated a social network to run pretty much entirely on Serverless. And it was there that I learned a lot about some of the challenges that we all face when we try to make applications run in production and still be able to debug and understand what the hell is going on. And some of my work has been captured by AWS and published in the Serverless well-architected white paper that they published just before reInvent last year. And last year was also the year when observability just became like this massive thing. Everyone was talking about it, everyone was writing about it. Every time you go to a conference, there's a whole track for observability. But based on what happened yesterday, it seems like even the people in this very room still can't agree on what observability means. So I think before I start, I should explain what I see observability and how it differs from monitoring. So to me, monitoring means looking out for those known failure modes in the system, like spikes in I/O, or CPU, or memory, whereas observability is probably closer to what security agencies around the world is doing in terms of auto-instrumenting the system and being able to observe from the outside what is happening inside and being able to understand how the system is behaving. So I'm going to go back to the first post I found on observability from Twitter a few years back when the guys were talking about all the problems and challenges they had with understanding what's going on inside this big, complex microservices architecture they have. And to do that, we need data from different dimensions, not just monitoring, but we also need tracing, we need log aggregation, and so on. And as everybody is building these big, complex microservices nowadays, the tooling has also evolved. And you have new tools that supports, that allows you to instrument your code and get observability from both the open source space as well as the commercial space. So all that is great, and I think even though we still have a lot of challenges remaining, but compared to where we were a few years ago, I think we are definitely in a far better place now than before. But then again, Amazon a few years ago announced this whole Lambda thing, and then now we've got a whole new paradigm of shipping and running software that we need to think about. And this new paradigm also introduced new challenges to the existing set of tools and practices that we use for observability. For starters, we've now lost the access to the underlying infrastructure that runs our code, which means a lot of tools that depend on having agents and daemons running on servers, there's just nowhere for you to store them anymore. And all these agents and daemons, or they do a very important job in that they stay out of the critical path where we are really concerned about user-facing latency. So they will collect the metrics and logs from your system, they'll batch them up, and then send them to the backend system later on. But with Lambda and other similar managed platforms for serverless, you've lost the ability to do background processing. Another important thing that has changed is how concurrency is managed. When our application is running inside a container or inside a VM, our code is responsible for managing the concurrency. Now with Lambda, concurrency has been lifted up into the platform, which in many ways is great for us, especially for us application developers. It means our code is now far simpler. We don't have to manage concurrency anymore. It's a problem that Amazon or Google or Azure is solving for us. At the same time, we've now losing that economy of scale in terms of how we collect and batch and send those monitoring data. Before, we do them at the application level, so at the instance level, and now the best you can hope for is to batch them at the function level in between invocations on the same container that's running your code. What that means is now In terms of concurrency, even in terms of the number of open sockets that we have to the backend system that we use for collecting this observability data is far greater than before, which means you're now putting a lot more stress on those systems that you're using. You might say, sure, that's a simple problem to solve. You just use a bigger batch when it comes to functions. Unfortunately, that's not going to work. Imagine when there's a new wave of traffic hitting your system, so in response, Lambda or some other platform provider would increase the number of concurrent executions of your function, so they will create new containers, load your code, and start running. And the first time your code runs, when a container is created, you get what is called a cold start. Essentially, that's when the container gets bootstrapped, the runtime gets loaded, and it initializes your code, including all the global variables and so on. So cold start takes a bit longer than a warm execution. Now imagine if you don't send metrics, you're batching them between invocations for the same container, and you only send them once you've got enough data or enough time has passed. What happens then when the traffic goes away? Some of those containers that was created is no longer necessary to sustain the current level of concurrency you have in the system, so they become idle. And after some time, the platform will also garbage collect them, along with any data that you've batched, but you have not sent to the backend system yet. So if you're batching and sending data like this, then you expose yourself to a high chance of data loss, potentially at a massive scale. But what happens if you just say, sure, we'll just send them at the end of every single invocation? What's the big deal? The problem is, now remember, you don't have background processing. So if you're sending it at the end of every single invocation, and with Lambda or other similar platforms, other functions of service, everything you want to do have to be done as part of your functions invocation, including sending custom metrics or just sending logs to other vendors you're using. That means your function takes longer to finish. And when you're building APIs with API Gateway and Lambda, it means API Gateway have to wait longer for your function to respond, and therefore your customer have to wait longer for your API to respond and for the UI to do something. So that means you're now kind of caught in between a rock and a hard place, where on the one hand, you can be vulnerable for data loss if you're batching and sending data. On the other hand, you are adding to your user-facing latency if you try to send those observability data eagerly. We will talk about some trade-offs, but even those trade-offs comes with their own set of trade-offs as well. Another thing you notice with Lambda and other serverless applications is that they tend to be a lot more event-driven nowadays. I think in part because technologies like Lambda and Kinesis makes building an event-driven architecture so much simpler compared to what we had before. And in general, we find that a lot of Lambda invocations are linked together via asynchronous event sources such as SNS, Kinesis, CloudWatch events, or in some cases even S3 triggers or DynamoDB streams as well. And trying to trace those asynchronous invocations is a lot harder compared to something more synchronous like an API call. And in some cases, you don't even have an easy way or a natural way to attach those kind of trace IDs when you send, say, a file into S3 or when you publish an event into Kinesis. So those are just some of the challenges that this new paradigm has introduced to the current set of tools and practices that we have for observability. I want to move on to some of the tools that we do have today in terms of the 4 pillars identified by the Twitter engineering team. And I want to focus on the tools that you get out of the box with AWS. Whenever your function writes to send it out, so that's if we do console.log in Node.js, then everything you write gets captured and shipped to CloudWatch logs asynchronously. And this is one of the few places where you do get background processing because it's provided by the platform. You also get a UTC timestamp, a request ID as well. And inside CloudWatch logs, the way it's organized is that for every function, you have a way it's called a log group. And inside that log group, you have different log streams, one of which corresponds to every single container that you have running your code. So that's all well and good for asynchronous collecting logs and putting them in one place, but CloudWatch logs doesn't make it easy for you to search them. In fact, you just can't search across multiple functions at the same time. So if you want to search for the same term across all of your logs, you've got to do them against every single log group you have, which of course just sucks. It's never going to work, right? So what most people do is they go to the console, they select a log group, and they say action and stream them to either the Amazon's host Elasticsearch or in most cases, you find people stream them to a Lambda function, and from there you can ship those logs to whatever log aggregation service you want to use. Could be a self-hosted Elk, could be logs.io, could be Splunk, could be anything you want. I want to also mention while I'm here that instead of just streaming to a Lambda function, you can also stream the logs to a Kinesis stream instead, which at scale is probably what you want to do because it gives you a lot better control around the concurrency you have. We'll talk more about a problem of streaming logs to Lambda later on. Another thing to keep in mind is that every time you create a new Lambda function, system also creates a new log group as well. And you really don't want to introduce a manual step in the process that every time I do a deployment, now I've got to remember to go and subscribe my log group to my log shipping function just so that the logs get shipped to my Elk stack. So what you could do is you can set up a CloudWatch event pattern against the create log group API call that the system makes on your behalf and link that to a Lambda function whose job is to subscribe this newly created log group with your log shipping function. And if you're using frameworks like Serverless framework, you can also automate this process as well by just putting in a few lines of YAML into your serverless.yaml file so that whenever you deploy, you get this out of the box. Another thing to keep in mind about CloudWatch logs is that by default, it's set to never expire. And when you consider you're paying per gigabyte per month, it's a great business plan for Amazon. And since you're also shipping your logs to somewhere else anyway, there's no point in keeping them in CloudWatch logs and paying for them forever. So what you should also do is apply the same pattern and have another Lambda function whose job is to then automatically update those retention policy to, say, 7 days or maybe even 30 days. In terms of monitoring, out of the box, you get a basic set of telemetries about your functions, including invocation count, duration, error count, throttle count, and so on. But remember, there's no background processing, so whenever you want to send custom metrics, so application-level metrics, then you're hitting this same problem again. You have to do it as part of your function invocation, which adds to your functions, your API's response time. You might say, sure, that's 10, 20 milliseconds on average. What's the big deal? The problem with that is when you have microservices, so often you have user actions that requires a number of hops, API calls, in order to complete. So those individually 10, 20 milliseconds can start to compound, and you can easily add more than, say, 100 milliseconds to your user-facing latency. And Amazon found a couple of years back that every 100 milliseconds of user-facing latency you add can reduce your sales by as much as 1%. So those additional milliseconds you're spending to send custom metrics can actually come back to hurt your bottom line. And one of the workarounds here is available here is basically what Datadog does, is you can write your custom metrics as a specially formatted log message, and then you can piggyback off the background processing you get already in terms of it getting shipped to CloudWatch logs, and then you have either through a Lambda function or through a Kinesis stream first, you can filter those out and then send them as metrics to your monitoring system instead. It sounds a bit wacky, and it kind of feels it is, but in terms of the constraints that we are working with, that's one of the few things that you can do. And that's why a lot of the tools that are now built specifically for serverless are doing that already. And of course, this workaround's got its own trade-offs. It's adding more delay for you to see your metrics since from the moment you record them, and it's adding more cost to CloudWatch logs, which has got something like, I think, 50 cents per gigabyte of data ingested, and also costs spending more money on Lambda invocations. In this particular case, we talked about why with CloudWatch logs and Lambda can be a difficult combination, because CloudWatch logs is an async event source for Lambda. So every time there's a batch of records ready, you invoke a new new instance of your function to process them. So at scale, that means you can essentially double the number of concurrent executions for Lambda for your entire environment. And remember that with Lambda, you have a soft limit of 1,000 concurrent executions per region, per second, well, concurrent execution per region, which means you can actually have this function that's processing logs eat up so much of your concurrent execution that user-facing APIs are now getting throttled. And that's not something that you want at all. So what you would do is you should at least control the concurrency for that particular function so that you cap it at some number that you're comfortable with. On the other hand, you do get the benefit in terms of not adding any overhead to your user-facing APIs, in terms of the latency that you add. So for APIs, I think it's something that's worth considering. But when you're doing background processing, and I know a lot of people are using Lambda just for background processing, just don't worry about it and just send straight to your vendor. So once you have all of your metrics in one place, set up dashboards, connect them to Opsgenie, PagerDuty, and whatnot, all the same things that we're used to doing. In terms of tracing, Amazon also provides the X-ray service out of the box, which does give you some visibility into what your function is doing. And interestingly, when you call another function via the Lambda API, you also see what happens inside that second function. But the trace doesn't work when it goes to API gateway. So if you make an API call to another API backed by a Lambda function, you don't actually see what happens inside that. So as far as the distributed tracing solution goes, it's probably not quite what you need right now. Another thing I found with X-ray is that it tends to focus very much on what happens inside one particular function. It doesn't tell you very much in terms of how the entire system or how workflow is working. And in one of her interviews with InfoQ, Charity Majors, she's the CEO for Honeycomb, she talked about how when you have a distributed system, the health of individual services is less important, and that's because it doesn't tell you the entire story. What you should focus on instead is on those user actions that tend to span across multiple parts of your system. So there, I want to follow the data as it comes in as a user request to the edge of my service, and as it goes through different parts of systems through both synchronous event sources like API Gateway, as well as asynchronous event sources such as S3 and Kinesis and so on. I want to see how the entire workflow is happening. So X-ray does give you a different view for your traces, but again, it doesn't span over API Gateway or asynchronous event sources. And of course, being an AWS service, it doesn't support the non-AWS services as well. So if you're using, say, Auth0, then tough luck. And one more thing I want to mention is that with X-ray, you've had the ability to then go in and press the refresh button to see new traces. But then this is still very much a static view of a system that's alive, that's constantly, things are constantly happening. And in general, I find that a lot of tools that we have today, they focus too much on what happens inside one function. And as we build more and more complex systems with serverless and Lambda, we're going to need a lot more help in terms of understanding the health of the entire system, or at least the health of the entire workflow that touches multiple functions. So going back to that social network thing I was building, and one simple user action could be I create a post and it gets distributed to all of my followers in exactly the same way that Twitter works. Even for a simple user action like this, for it to happen, you need to have multiple Lambda functions need to work together across both synchronous event sources like API Gateway, as well as asynchronous event sources such as Kinesis and SNS in this particular case. And as we build more and more complex systems using serverless, we're going to need a lot more help from our tools and our vendors in order to be able to debug and troubleshoot those complex user actions. And with that, I want to switch gear and talk about what the future of serverless observability could be based on some of the things I've seen being developed in tools that should be coming out to the market pretty soon, as well as some of my own ideas. Starting with dashboards. I'm pretty sure like everybody in this room, I've used a lot of dashboards in my career. So many of them, in fact, and by and large, I dislike almost all of them. To me, no offense to any vendor, to me, it just feels like a lot of these dashboards are designed to overwhelm me with information. Even the ones I designed myself, it always seems like a good idea at the time. Let's add one more thing to the dashboard. I might want to know that at some point. Just like, let's always pack a bit more into our luggage when we go traveling. And when you actually need to look at the dashboard and understand what the hell's going on, you just get overwhelmed with all this information. And for every single bit of useful signal, there's just so much noise that I have to filter out myself as a user. And another thing I find is that I get this mental dissonance there whereby I want to think in terms of the health of service or functions, and that's what a lot of tools seem to be focusing on. But then the different dimension of data I need to look at to understand the health of any one thing is splattered all over the place. And I have to somehow find them across all of these segments. Some are there, some are there, some are hidden in this kind of bush here. It's just really hard to correlate and build a complete picture myself. And of all the dashboards I've used, the one that I enjoy the most, that I actually like using, is the dashboard from Hystrix library by Netflix, whereby all the relevant information about one particular component is visually encoded together. And the two most important information, the volume of traffic and the general health of that component, is also encoded as the most prominent and visually striking part of the dashboard as well. Of course, for Lambda, it's missing some critical information, like the number of cold starts, the number of throttled and concurrent executions, and maybe the estimated cost, which we can actually easily calculate based on the configuration for the function and the number of invocations and durations. So if we take what the Netflix dashboard looks like, so Histrix dashboard looks like, and give it a makeover and make it work for serverless. So we can include the number of cold starts in absolute terms, as well as in terms of the percentage of invocations in the last, say, 10 seconds. We can add an estimated cost per second based on, again, on the memory setting for the function, as well as the duration and number of invocations and so on. We can also add the number of concurrent executions that currently have and the number of timed out or throttle executions that we have as well. And it's all well and good having a dashboard that shows you the basic health of individual functions or services, but it still doesn't tell you very much in terms of how the different components work together. Specifically, I'm interested in how the user requests and data flows through the system as across different functions. And the way that I like to visualize my application or my system as a whole is like a brain, where you've got neurons and you've got synapses that connect them that allows data to flow from one part of the brain to another. And if you want to see how the brain reacts to external stimuli, what you do is you put that someone into an MRI machine, and then you can watch in real time as the different parts of the brain light up when you inject some external stimuli, like pinching their arm or tickling them or something. And for that, I really like what the Netflix guys have done with Visceral, which allows you to watch as the request flows through the system in real time, or how traffic is being diverted when there's an outage in one of the regions. When a dashboard is live like this, rather than being static, it gives you a bird's eye view into your system as it lives and breathes. And maybe occasionally you want to just take a pause and just dive into one of those concurrent executions and really dive into it and understand what's going on. And this is where I want to see how the different parts of the system is connected together, and including anything that goes over asynchronous event sources as well as synchronous ones. And I also want to see when my system crosses over the AWS boundary and uses services that are not part of AWS. And instead of having to jump between different views and different tools to gather all the different pieces and then stitch them together into a mental picture of what is actually happening in my head, the tool should just have all the information right there at my fingertip. So when I'm looking at this particular invocation trace, so a workflow, all the relevant logs for that particular workflow should be right at my fingertip, with the same usual UX treatments in terms of being able to sort by column heading. And if I click on one of these rows, it should expand to show me other relevant attributes like correlation IDs that's been collected. And if I click on one of the functions, you will filter out and show me just the logs for that particular function. And since the system even knows that I've clicked on the function, maybe it will show me the tooltip that says, hey, do you want to just open up the code in, say, a Cloud9 IDE, so that you can quickly see the code alongside the logs that's generated by this piece of code. And I also want to see the input and output for my functions. So when I click on a different function, it should show me the input and output for that particular invocation. And if one of the functions errored or timed out, I also want to see the error message alongside the stack trace if one is available. In fact, the UI should flag them so that visually I know straight away to look at that function because something obviously gone wrong and requires my attention. So that's all well and good. What else are we missing here? Right, we're also missing the traces. I'm interested in how long the entire workflow took, as well as the breakdown for the different steps and components. So if I click on one of the functions, it should highlight just the traces relevant to that particular function. If I instrument my code, it should also show me the breakdown based on those instrumentation, and preferably, it should just also auto-instrument my code for me as well. And the idea here is that I should have one place that can satisfy all my tracing needs, rather than, again, having to jump between different tools to build up a mental picture of what's actually happening. The information shouldn't be fragmented like that. They should all be there, easily accessible from one place. Another thing that strikes me when I look at the Visceral Tools UI is that I'm actually looking at a graph, as in there are nodes and there are vertices that connect them. So what if, and this is a pretty big what if, we can store the data as a graph and query them as a graph, as you would do with a graph database like Neo4j or Amazon's new Neptune database. That's going to give me the ability to query my metrics based on relationship between different components, as well as based on the metrics, the data points available for individual components as well. So in the case, whenever you do a root cause analysis, ultimately you're looking for that causality that helps you answer the question of what caused some abnormal behavior that we were able to observe or was being reported by our users. So suppose you got some slowness in the payment service yesterday at some moment in time, and when we start investigating these problems, we typically start by looking for other abnormalities in the whole system, only going off by temporal correlation. But that temporal correlation doesn't necessarily mean causality. Oftentimes I find that it's difficult to tell the cause from the symptoms, especially when everything happens at the same time and symptoms appear at different stages depending on the component you're talking about. And it's hard to identify those, to tell the difference because some of those relationships may not be obvious to us straight away, and that's where we have to defer to expert intuition, as we heard on the first day, where an expert can look at the different graphs and straight away figure out that that's causing that, because some of those relationships may only exist in their own mental model of the system, but is not explicitly captured and documented elsewhere. So now imagine those relationships can be captured and queried upon explicitly. We know the payment service was slow. With a simple graph query, we can find all the different services that has got a causal link to this payment service. So anything that's used directly by the payment service or indirectly by those other services, we might be able to focus and narrow down our search for abnormality in the system. We might find that, okay, turns out the database that's being used by the user service was being throttled around the same time, and because the user service is being used by the payment service, and that was what's causing the slowness we are seeing in the payment service. Now you found the root cause, you can also use a graph query to then expand your search and look for other things that may potentially be impacted by the same abnormal behavior as well. Maybe some services you just don't, maybe the errors are just not as prominent, so they don't show up and get captured and alerted by your monitoring system. But nonetheless, those are all the things that could potentially also be impacted. And with a quick query, so a quick filter, you can also filter out anything that's, that has got an error rate less than, say, 5%, or the 99th percentile latency is not greater than 1 second, and so on. Ultimately, I think having the extra dimension that we're able to query our metrics data on is going to be really powerful for us if we can ever make it work. Also, with the last couple of years, we've heard a lot about big data, machine learning, deep learning, and so on. And I think as an industry, we've gotten pretty good at using those technologies and know-how to improve our products and services. So what about if we turn around and try to apply the same know-how and technologies to how we operate our own services, and we can maybe use machine learning to help us auto-detect the suspicious behaviors or auto-suggest potential improvements that we can make. Amazon's already doing this with their Guard Duty and Macy's services already. So imagine now there's some background process monitoring everything that's happening that our functions are doing. It might say that, oh, wait a minute, this particular function is now starting to use some resource that is never done before. It is right. And if I'm in the UI watching the dashboard, maybe it can pop a little something that I can do something, I can respond to that straight away. Or if I'm offline, maybe you send me an email from some bot account where I can say, nice, fine, we know about this, it's a new feature, it's a new thing that we're doing. Or, oh my God, something's happening. Let's quickly stop what's going on by modifying the IAM role for that particular function to put a deny rule against whatever it is that it's doing that we don't think it should be. And also, you may be able to find that, oh, since you did that deployment to this function yesterday, performance in terms of latency has now gone up by 40%, so maybe something that's worth looking into. Or that, hey, one of your functions is averaging about 102 milliseconds execution time, and based on the way that Lambda charges you in 100 millisecond blocks, it means that you're actually paying for 200 milliseconds. So maybe you should consider running the function on a higher memory setting, which gives it also more CPU power so that you can hopefully bring down your execution time to below 100 milliseconds. So you have a function that runs faster and also you pay less for it as well. And that's just some of the things I've been thinking about in terms of what the future of serverless observability could be. That's actually my cat. I named her Ada, as you know, Lovelace. But I don't have a crystal ball, so I can't really tell you what is going to pan out in the future. What I would say, though, is people like Simon Wilder has been saying for a long time now that businesses need to develop a sense of situational awareness. And to do that, they need to use tools that give them the context and movement of the space that they're working within. And as engineers that are building complex systems where we care about the health of those user actions in our system, we are also going to need tools that can give us both the context and movement of data to help us build up those situational awareness of the system that we're working with, or the expert intuition. And as the great man Alan Kay once said that the best way to predict the future is to invent it. I will follow that by saying the best way to invent the future is to inception someone else to do it for you. Which has been the entire purpose of me being here today, telling you what it is I want from my tool. So thank you very much.